my name is Nako Nakatsuka. I'm a fourth year chemistry PhD student at UCLA, and today I'll be helping you guys out by going over some general chemistry concepts. And good luck with the course. So since cell potentials are sensitive to the concentrations of reactants and products, we can make these galvanic, also known as voltaic cells, which I've been showing you in this Chem chapter. We can make the same exact components at different concentrations. And this is called a concentration cell. So remember before we had two different electrodes, right? For example, we had zinc here as the anode and we had copper here as the cathode. In a concentration cell, we have the same components. So we have silver wire here, we have silver wire here. The only thing that's driving the reaction is the difference in the concentration. And so in a concentration cell, the standard potential at standard conditions is always 0 volts. And when we make these cells, we always make the lower concentration the product. So this is a very important thing to remember. And so as an example here, let's set up this equation where we have silver plus at 1 molar, going to silver plus at 0.1 molar. And so as you can see, we're going from a higher concentration to a lower concentration, where this is the reactant and this is the product. From here, we can use the Nernst equation that we saw before, where we have negative RT over NF ln Q, where this is the concentration of the products over the concentration of the reactants. So Q is going to be 0.1 molar over 1 molar. And remember, this standard cell potential is going to be 0 volts for a concentration cell. So when you actually end up plugging in the values for the temperature, the gas constant, the number of moles of electrons, in this case just 1 electron, right? And Faraday's constant, which we saw before, is being 96,000. What was the 96,485 coulombs per mole. And since it's at standard conditions, temperature is just 25 degrees Celsius converted to Kelvin. And when you actually do this yourself, you're going to end up with a value for the cell potential. And in this case, it's going to be 0.0592 volts. So you can try this yourself and see if you get the right answer. But as you can see, you can also create these cells by using different concentrations on both sides of the same element. So to conclude this chapter, I wanted to mention one more term that you might come across, which is electrolysis. And what electrolysis is you use an electron current to drive a non-spontaneous reaction. And in particular, a redox reaction. So electrolysis takes place in electrolytic cells where electrical energy is converted to chemical energy, like what we talked about when we first started this chapter. So electrical energy to chemical energy. And remember when we were looking at these concentration cells or galvanic cells, we were converting chemical energy to electrical energy. And so this is another term that you might come across, but for the most part for Chem, at this level, we talk more about the concentration cells and galvanic cells, and you should make sure that you know how to use the Nernst equation to solve different problems.